Let's imagine that you have a very successful oil extraction business in Siberia, or something related to oil extraction, since what else can you possibly be doing in Siberia? During a rare vacation, you visit India and developed a soft spot for spicy food, for Indian curry. Yet, when you come back home, no more spices, no more curry. But you're pretty wealthy, business goes well, and usually whatever you want, you can get. But what about Indian curry? We can figure out logistics for supplies and other arrangements, but a chef can be considerably reluctant to go to Siberia. So getting a meal that requires less than $1 in India or a fiver somewhere in London becomes almost impossible to get in Siberia. Kind of makes me think how relative the value of money is in relation to what you can and what you cannot do with it. But where did the conditions come from? The same event, getting Indian curry, naturally occurred in India, but in case of London someone has had to do some work in order to make that event possible. And that quite likely did require investment of time and energy of people for creating a path towards something that didn't exist before. And similar to how the difference in logistics can lead to different time and money investment required, we can think of any path between cause and effect in terms of energy spent along the way. Some paths are very friendly, but some can have considerable obstacles associated with them. For instance, an Indian chef might not go to Siberia even for good money, just because it is so cold. So there is some additional resistance associated with this path due to environmental conditions. We could draw paths to possible events and see how much energy it would require to accomplish one or another. Maybe it would be easier just to get nice pancakes and forget about all this curry business. Otherwise, one may be so distracted that it would be impossible to enjoy things which are already present. Physics teaches us that events prefer paths of lowest resistance. Water flows where the reaction of the medium is minimized, and when multiple paths exist, multiple flows occur. Still, the intensity of any flow depends on properties of a path a flow takes. In electrical engineering, there is a neat equation called Ohm's law, which says that a flow of electrical charges, electric current, is directly proportional to applied force, or voltage, and inversely proportional to the resistance of the path a flow takes. When multiple flow paths are connected, they form a network, and laws which describe the relation between flows and forces are fundamental to circuit theory. They are called Kirchhoff's laws, and they essentially say two things. Currents are continuous, so when several paths meet forming a junction, the total inflow is equal to the total outflow, and that for any closed loop, the total voltage drop is zero. There is also an important consequence that the voltage drop along parallel paths is the same. These laws are equivalent to the laws describing fluid motion when voltage is substituted by pressure. Circuit models are actually very useful. It is possible to construct one pretty much for any process where energy is choosing a well-defined path, like a copper conductor or a metal tube. The form of the relation is always the same. A flow produced by a force depends on some properties of the path a flow takes. Now think about our curry problem. All obstacles contribute to the resistance of the getting Indian curry path. So assuming that the money acts as a force, the flow of event that money can produce is non-existent. Fortunately, other paths might be much more conductive. But what if there is no well-defined path? What if we are in a plane of infinitely many equal possibilities? Then we come back to the field theory once again. Paths have a tendency to concentrate possibilities. Alternatively, we might get equal flows in all directions, like in case of light emitted from a star. And yet, there is something weird about possibilities, in a sense that two distinct possibilities can lead to something else or nothing happening. It is hard to see how two roads can add up to no road at all, but hear me out. Whereas a particle, say a photon, does interact as a particle, its motion, or probability of interaction, can produce interference patterns. This phenomena is inherent property of waves. Usually, when we add values like 20 and 40, we just get 60. But for periodic phenomena, frequencies and phases also matter. So it is no longer about simple addition. Here, on the left side, waves are in phase, so they enhance each other, whereas on the right side, waves are out of phase, adding up to nothing. Yet, when interaction actually happens, particles interact as objects of fixed energy, which gave rise to a very persistent and confusing duality problem. Yet the confusion starts to fade if one separates interactions in which particles are involved from their possibility to happen. This idea permeates all of the quantum physics, and its origins can be traced back to the work of Louis de Broglie, who proposed the existence of a phase wave associated with every object. Phase wave is a wave that transfers phase instead of energy, and phase is associated with possibilities. And one of the consequences of this proposition is that motion of massive particles, as well as massless particles like photons, is subjected to interference. I must emphasize that it isn't even about multiple particles interfering with each other, since motion of a single particle can produce diffraction patterns as well. We are now approaching the classical example of the weirdness of quantum world as demonstrated by the double-slit experiment, and I don't want to go there just yet. What I'm emphasizing here is that there is something about possibilities interfering rather than objects, and possibilities can be conveniently characterized by paths. Interference occurs since in general a particle might follow all possible paths, however improbable, yet one can never know which path it will take at any exact instance. So it is necessary to consider all paths, all possibilities. Since paths can interfere, they can cancel each other out, or enhance some options at expense of others. There is a neat way to show that this idea works. There are classical ways to show that light will go between 2 points along the path of minimal time, or simply in a straight line. Our path proposition suggests that we consider all paths, both false and true, but each path on one side has its mirror copy on the other side, and they contribute opposite phases. So all possibilities add up to the same path, which geometrical optics predicts. One might also guess why we don't observe interference patterns macroscopically. As the system of particles becomes more and more complex, from the space of infinite possibilities just a few will remain, and events will become as deterministic as the inevitable landing of the falling apple. So summing up, paths lead to events. Paths can be characterized by how conductive or resistive they are, and on fundamental level, distinctly different options can interfere with each other. One might notice that Ohm's law doesn't predict interference or quantum effects and label it as incomplete. Yet, it is very useful for the area of its applicability. I actually think there is a lesson to be learned from Ohm's law. In order to transfer more energy, one can either increase voltage or decrease the resistance. So instead of pushing harder, one can spend some energy onto making the path more conductive. So maybe there is a smart way to get Kari to Siberia, since humans have a tendency to sometimes ignore simple solutions. But a path needs to be created, and someone needs to do some work to make that possible. After all, bridges can be built, and someone has had to do some work in order to make anything possible, whether that was ingenuity of human beings or our Mother Earth. Thank you for watching, and see you next time.